Today we're going to cover a modular arithmetic problem, and this is a second degree or quadratic expression that we're interested in right here. So a couple of formulas that are certainly you would think would be necessary would be what is the solutions to a quadratic equation and what does congruence actually mean. And this congruence symbol sometimes is related to is modular arithmetic. Now, just to be clear, y'all probably know a lot of this already, but let's just do a concrete example here. Let's see here. I'm trying to think of a pair of numbers here. 22 would be congruent to, let's see, I'm trying to do some calculations here. 22 would be congruent to 8 mod 7. Okay, and you'll notice that 22 minus 8 isn't that 14? Yes, it is. 22 minus 8 is 14. And so notice that the difference is divisible by 7. So let me finish this up here. Mod 7. Okay, and that's because 22 minus 8 is divisible by 7. And y'all, I'll use this symbol here. The vertical bar means divides, or that means 7 is a factor of 14. So 7 certainly divides 14. And I'll write 22 minus 8 just to be clear. Won't do any more. All right. 22 minus 8, and let me do that parenthetically. All right. So again, y'all, 22 minus 8 is 14, and 7 divides it. Okay, so that's the meaning of congruential, the congruent symbol. Okay, now let's get busy solving the problem. We're looking for solutions to this problem, and so it makes sense that the quadratic formula would work, except we always have to remember we're mod 11, okay? And so I just applied the quadratic formula here, and you guys can go through this, but we get x is equal to negative 7 plus or minus the square root of the quantity, 7 squared minus 4 times 1, which is just an immediate application of the quadratic formula up here. Now again, we're doing all this in module 11, so let's keep that in mind. Now, so folks, right here, the arithmetic simplifies to what you see in front of you here. Minus 7 plus or minus root 33 divided by 8. Now, notice that 33, and I'll just write it down, 33, and it's clear that we're working, let me write it over here, 33 is congruent to 0. All right. All right, and so that means on the very next line, we can literally replace, and you can see what we did right here. We replaced 33. Here's 33. It got replaced with 0. So congruence behaves very much like equality, almost identical to equality in a lot of circumstances. Okay, so again, 33 is equal to 0, modulo 11, so we can replace 33 with 0. All right. Now, in a similar fashion, you'll notice on this next line, 4 minus 4 is congruent to negative 7. Okay, 4 is congruent to negative 7. And again, we're dealing mod 11 because 4 minus a negative 7 is 11, and 11 is divisible by 11, right? So that's why this minus 7 got replaced by 4 in this line. Now, we looks like we're in a roadblock right here because we're dealing with integers, and we have 4 over 8, and you say, well, isn't that 1/2? Well, yeah, it is when we're doing real arithmetic, but remember, we're doing modular arithmetic, and so a useful convention right here is to actually talk about what this might mean. Okay, so we can rewrite this as x is congruent. And I've seen multiple symbols used right here. We can rewrite this guy right here as x is congruent to 4 times, and we'll call it just what you're used to calling it, sort of, I guess. 4 is 4 times 8 inverse is what I'm trying to write down here, folks. 4 times 8 inverse. Okay. Remember, now it turns out it's not, it's just what the symbol means actually. So what we can do right here is realize that this means the very same thing, meaning if you write down, and this takes a slight bit of work, but if you multiply 8 times 7, okay, if you multiply 8 times 7, that turns out to be congruent. And this takes some work here, folks. I just, you have to think about it a little bit. I'm going faster than I would if I was just doing it by hand. But so 8 times 7 is congruent to 1 mod 11. So you see 8 times 7 is literally equal to 1 mod 11. Okay? And you guys can verify that, but 8 times 7 is 56, right? 8 times 7 is 56. And so 56 minus 1. 56 minus 1 is 55, and that's divisible by 11. Now, how is that useful? How is that useful? We see what we can do now I'll just come down a little bit further here. You're a good deal. I got room here. So we can write down that x is congruent to, and y'all, what this really means is that the 7 that you see right here would be the same as 8 inverse. Okay? Because in regular arithmetic, something divided by itself is equal to 1, right? Well, the same thing works here, just you're having to stretch the language a little bit, right? So we can write down that x is congruent to 4 times 7. Isn't that cool? Okay, but that's equal to 28. That's equal to 28, which is congruent to 6 mod 11. And y'all, I'm leaving that to you, but 28 minus 6 is what? 22, and 22 is divisible by 11. Now, so the claim is, just like, we essentially had a discriminant that was equal to 0, right? If you go back up here, if you go back up to the top here, this discriminant 33 is literally equal to 0. And you can remember what happened in the classical case, or just the college algebra case. That just means there's going to be one solution, right? So the claim is that 6 would be the only solution. Now let's verify that right beneath right here. So I'll just write down the results, y'all. 4 times 6 squared. Okay, 4 times 6 squared is 4 times 36. 4 times 36 is, 144? Well, I'll just write it down. We have 4 times 36. Again, y'all, I'm squaring 6 plus 7 times 6, that's 42. And y'all, what we're doing right now is checking the answer. Okay. Now, that's equal to, let's see, 144 plus 142 is 186. So, ladies and gentlemen, I'm getting 187. Okay, now, the question is that divisible by 11? I believe it is, because isn't 187 equal to 11 times, what do we need? 11 times 10, 11 times 17? Yeah, 11 times 17, right, folks? Okay, so in other words, 11 divides 187. Okay, so that means that this does check as the answer. Now, just a word. 6 is what they call the least positive integer. That would be the solution to this. There's plenty of others. For example, -5 would also be a solution. If you wanted the largest negative number solution to the equation, it would be -5, because -5 is congruent to 6. Okay. But notice there's all kinds of others. If you want some larger positive numbers, you might try for, let's see, what's 17, 23. You could do 17. You could do 28, right? All of the, you can string congruences together just like their equalities. Okay. It's supposed to be at 28, folks. Okay, 28. But y'all, the answer I was looking for was 6. I should have been more precise the way I asked the question. But that's the end of that. I hope you liked it.